In this video, we're going to practice solving for a variable where the variable that we are solving for appears more than once in the equation. So for this particular equation, I want to solve for y. So as always, the variable that I want to solve for, I need to isolate on one side of the equal sign. So what I'm going to start with is I'm going to take this term that has a y in it. So I'm going to subtract by. That becomes 0. And I'm going to bring it over to the left side. So now what I have is ay minus by equals, plus 4 equals 5. So now I have both y's on the same side. So now I need to move my number to the other side. So I have my variable isolated away from the actual number. So here we're going to subtract 4 from this side to get 0. 5 minus 4 is 1. So our left side still reads ay minus by equals 1. Now I need to get just a single y so that I can solve for a single y. So I'm going to fall back on the fact that this y in this binomial is a greatest common factor. So I'm going to use my factoring skills and factor out a y, which leaves me y times the a minus b in parentheses equals 1. So to simply get y by itself, I need to divide by whatever number is in front of y. In this case, my number is made up of the expression a minus b. So I'm going to divide both sides by the expression a minus b. So now this side is 1y, and the other side I just simply write as is 1 over the expression a minus b. Now I'm going to have you try one. I want you to try to solve this one for y. Pause the video, try the problem out yourself, then unpause the video and check your solution against mine. So to solve this one for y, I see that the y is showing up twice in my equation. So I'm going to need to get them both over to one side. So on this side, I'm going to subtract yp. And so now both my y terms are on the left. So I have yk minus the product yp plus 6 equals 10. So to continue isolating the side with y, I need to move my constant, number 6, over. So 6 minus 6, which is 0. 10 minus 6 on this side gives me 4. So now I have yk minus yp equal to 4. So to isolate the y, since it's here twice, I'm going to factor it out. And I'm going to get y times the expression, that actually should be k minus p equals 4. So now, to get y by itself, I'm going to divide by the expression k minus p on both sides of the equation. K minus p. So y is isolated because these two expressions are equal and they divided to equal 1. And so now I have my expression 4 over k minus p.